A very good morning, students. Today we are going to see with what is meant by surface tension. Okay, so what is a surface tension? It is a force which acts in the liquid. Okay, so when you consider the liquid surface, so within this liquid surface, a force is acting. Okay, and that force gives rise to this surface tension. So surface tension is nothing but a force. Yes, so for this the main term we have to know is the intermolecular force. Yes, so what is meant by a intermolecular is the force which is between the molecules. Okay, so when you consider the force between the molecules, they are said to be the what? Intermolecular forces. Now consider different liquids which do not mix together due to their physical properties such as density, surface tension, force, etc. Okay, when you consider different liquids, and if you just mix those liquids also, those liquids will not mix together. Why? Because of the density, and the next one is the surface tension force. Okay, an example we can say water and kerosene, it do not mix together, is it not? And because of what? Because of density as well as a surface tension. And next is the mercury do not wet the glass, but the water sticks to it. So when you consider mercury and the water, okay, in the glass, the mercury will not stick to the glass, but in the water we can pour it. Yes, and water rises up to the leaves through the stem. Yes, and we know this is which is occurring in the plant. Yes, so through the stem the water is going up to the leaves. Yes, then they are mostly related to free surfaces of the liquid. So these are all the properties which are related to what? The free surface of the liquid. Okay, and so we can say that the liquids do not have any definite shape and definite volume. Okay, so the liquids do not have any definite shape and definite volume. So whatever container we are pouring in, it takes the shape and the volume of the container. Okay, hence they acquire a free surface when poured into a container. So any shape of container if you are pouring, it just takes the shape of those container. Okay, therefore the surfaces have some additional energy. Okay, and so this surfaces will have some additional energy, and that energy is called as what? The surface energy. Okay, because of the container, okay, there is some additional energy, and that energy is called as what? Surface energy, because of the surface. Okay, so in the surface nala vara energy, adanal da enadhu adukku peru surface energy. Clear? Then the phenomena behind the above fact is called as what? Surface tension. So this are all based on the topic what is called as a surface tension. Clear? Then consider the molecules of the liquid are not rigidly fixed like in the solid. So when you consider solid and liquid, okay, consider this to be a solid, okay, and here we have the liquid, and here if you see all the molecules are tightly fixed and they do not move, is not? So this is a case of solid. Yes, and here the molecules are not rigidly fixed, they can move about wherever they want. Okay, since they are loosely packed. Yes, so the molecules of the liquid are not rigidly fixed like in a solid. So they are not fixed as it is in a solid, they are free to move about. Okay, okay, so they can move about freely. The force between the like molecules which holds the liquid together, that is called as a cohesive force. Okay, so we can say the like molecules is when you are considering with the two liquids which can mix. Okay, and those two liquids, the force between them, that is called as what? Cohesive force. Okay, and same way when the liquid is in contact with a solid, the molecules of these solid and the liquid will experience an attractive force, and that attractive force is called as what? Adhesive force. Okay, so when you just make contact with a solid and a liquid. Okay, so when you consider solid and a liquid, and here is when you are considering with the like molecules. So like molecules, the force between them, that is called as what? Cohesive force. And if you consider a solid and a liquid, so the force between them, that is called as what? Adhesive force. Yes, clear with what is cohesive and adhesive force? So the force between the like molecules which holds the liquid together, that are called as a cohesive force. And when the solid and the liquid, they interact and they experience an attractive force, and that type of force is called as what? Adhesive force. Yes, clear? So next is, so consider this to be a beaker, and these are all the water molecules. Okay, and consider three position of the molecules. One is A, B and C. Okay, so when you consider the position A, we can see that all the molecules which are around this, that is also inside the water. Okay, and so they experience no force, hence the net force is equal to 0 for the particle A. But next is, when you are considering the particle B, it is 3/4 is inside the water and 1/4 is above the water. Yes, and here it experiences a force in the downward direction. So why it is experiencing in downward direction is maximum part is in the downward direction. So it is experiencing in the downward direction. Here the force is equal to what? Force is equal to 0. And here it is experiencing the downward direction. Third condition is the position C, where part is inside the water whereas the remaining is outside the water. Yes, and here also when you see, this will have the force in the downward direction. Why it is so is because all the water molecules will attract this object inside, and so this also will experience a force which is in the downward direction. Clear? So we'll see with that. Consider three different molecules which is A, B, C in a given liquid. Molecule A is well inside the liquid, so within the sphere of influence, so fully it is inside the liquid. And so since this molecule interact with all the molecules in all the direction, net force is considered to be 0. Okay, so for the point A, the net force is considered to be equal to what? 0, because all the direction, all the forces are interacting, all the molecules are interacting. Okay, then second condition is, consider the molecule B in which 3/4 lies below the liquid surface and 1/4 lies on the air. Okay, here also since 3/4 is below the liquid, it has a more molecules in the towards the lower side than in the upper side, so it experiences a force in the downward direction. Okay, in a similar way, if another molecule C is chosen, upper half in the air and lower half in the liquid, yes, for this particle also, it experiences a maximum downward force. How it is so is because due to the availability of large number of liquid molecules on the lower part, because we have large number of liquid molecules and we have a small object which is over. Since water molecules, it is large in number, we can say that it experiences a downward direction. Okay, it is obvious that all the molecules of the liquid that falls within the molecular range inside the liquid, and so it experiences a downward force. Okay, so only the part A, which is wholly inside the liquid, will experience no force, while the other two experiences with a downward force. Yes, clear with this? Okay, then when any molecule is brought from the surface, that is towards the surface from the interior of the liquid. Suppose consider that this is a liquid, okay, and this is an object which is inside the liquid. So let us consider this to be the surface of the liquid. From the interior, if you are going to bring any object to the surface, till the surface if you are going to bring, what has to be done is some work is done, okay, against the cohesive force. So here the cohesive force is acting. So against the cohesive force, some work has to be done. Okay, and that work done is stored as a potential energy. So what work is done to move the object, that is being stored as what? The potential energy. So molecules on the surface will have greater potential energy than that of the molecules interior of the liquid. So on the surface, the molecules will have greater potential energy than the molecule which is inside it. Yes, clear. But when you consider for a system to be under stable equilibrium, when any system is in the stable equilibrium, potential energy must be minimum. Okay, so for stable equilibrium, what is the condition is potential energy should be minimum. So in order to maintain stable equilibrium, a liquid always tends to have minimum number of molecules. For this reason only, this liquids will have the minimum number of molecules. In other words, the liquid tends to occupy a minimum surface area. So it occupies only a minimum surface area, and so this behavior of the liquid gives rise to surface tension. Okay, so this behavior in which only very few molecules are being there, and that gives rise to the property called as what? Surface tension. Clear. And here we have the example of surface tension. Consider water bugs and water striders. Okay, and those insects, what it does is they walk on the surface of the water. Okay, so when you consider this to be the surface of the water, water bugs as well as the water striders, they walk on the surface of water. How it is so? Yes, that is due to the surface tension. Yes, the water molecules are pulled inwards, and the surface of the water act like springy or stretched membrane. Here what is happening is water molecule is being pulled inside, and this at this place it acts like a springy or the stretched membrane. Okay, this balances the weight of the water bugs and enables them to walk on the surface of water. Okay, so here the water is being pulled inside, and this acts like a spongy membrane, and so that they will be able to walk on this. Okay, so this phenomenon is called as what? Surface tension. Okay, so this is our example of surface tension. This is the second example where the hair of the painting brush cling together when they are taken out of water. So this also you might have seen. So if this is uh, a brush which you are using, and if this brush is inside the water, what happens is all the hairs will just move away. Okay, and when it is taken out, what happens? They just cling together, they just come together like this. Okay, this is because the water films formed on them tend to contract to a minimum area. So because of the water films, they make a minimum area. Okay, water always makes with a minimum area, is not? So that is being proved here.